So by the way, what is Newton's law of cooling? What does he say? Yes, Akhil?
Sir, yes, sir.
Yeah. So what is Newton's law of cooling?
I forgot, sir.
Forgot? Okay. Then let's start with some basic. Okay, this all comes under thermodynamics and thermal properties. So first, the law, what law says? The law states that the rate of loss of heat from body is directly proportional to mean difference of temperature. Mean difference of temperature. Temperature of what? Temperature of
Body.
Body and surrounding. Temperature of body and surrounding. Or we can say difference in temperature of body and
Surrounding.
Of body and
surroundings.
Surrounding. So if you keep repeating with me, you will learn itself. It will be easier so that you don't have to spend another time for learning.
Yes.
Okay. So what it says, the law states that the rate of loss of heat from the body directly proportional to difference between temperature of body and surrounding. Okay, but provided we don't access the temperature.
Yes.
It's provided excess temperature is very small. Okay, so this thing, where can we apply this? Yeah, you're applying a daily life. Give me example from daily life.
So, sir, like heating of WeXL.
Yes. Or even what you do when your coffee is hot or when your milk is hot, what you will do? You will keep there for a few seconds or few minutes, right? See, when your coffee or milk is hot, so what will you do? You will directly start drinking with that hot coffee, or you will wait, or you will like transferring some flat container to make it cool, right? Okay, yeah, I got disconnected.
Yes, sir.
Okay. So, as I was asking, you might have said something, but I didn't hear.
So what, keep it under a fan.
Fan, yes. Fan or just a flat container. Right?
Yes.
Yeah. So let's take example, like same example. So Newton's law of cooling. Example you can apply on cooling a coffee itself. Right? That example. See, this I'm writing so that you can understand, you can remember this way. Easy way to remember.
Yes.
Cooling a coffee. Cooling of a cup of coffee. It kept on table. Or any other way, any other example we can say? Even from walls, right? In in hot summer, from the walls, like same thing. See, same thing is happening at you loss of heat from the walls,
Yes, yes.
right? Walls of the room. So many examples we can say.
Yes.
Okay. So let's derive this equation. You need equation only, right? Let me see the question. You asked derivation, no? Deriving of this equation.
Yes, sir.
Let me check what was the question. Okay, explain and state Newton's law, conditions under Newton's law is applicable. Yeah. State conditions also, right?
Yes,
Okay,
sir.
very good. With that, we can do some numerical also. So it will be easy to understand. I think so you have already in that.
Yes.
Okay, let's do it. So let's derive this equation first. Okay, so we need to derive for delta Q. Okay. So let delta Q be the energy or energy emitted by the body. Emitted by body for a time delta T seconds.
Yes.
So mean temperature will be theta 1 and theta 2, right? That's what we wrote here. What is we need mean temperature also? Difference in temperature
Yes, sir.
of body and
Surrounding.
surrounding. Okay, so theta equals to 1 by 2 half of theta 1 plus theta 2. Mean temperature, 2 object divided by 2.
Yes.
This way we find mean, right?
Yes, sir.
So where theta 1 is temperature for first body.
Theta is for second body.
Another body, or we can say this way also, before and after.
Yes.
Either way, it will be same. Now suppose if we assume like theta 1 is the temperature of hot body and theta 2 at end,
Yes.
at the end of something. Let's take it as at the end of interval.
Yes.
So we wrote here delta Q by delta T is proportional to difference in the temperature. That's the definition, right?
Yes.
Theta minus theta naught. Now theta naught is temperature for surrounding. Theta naught is the temperature of surroundings, and then what is theta?
The theta.
It's a mean temperature. Here only we
Yes,
did,
sir.
right?
Yes.
It's a mean temperature. In your book, they're using theta or something else.
Yes.
Yeah?
I think it's theta only, sir. I think.
Theta only, right? Because it depends upon book to book. They are
Yes.
using different notation. Okay. Mean temperature of a body.
Yes.
Okay. That's it. Yeah, T we forgot. So to remove this proportionality, what we'll do? Delta equals to K theta minus theta naught. Theta naught is temperature for surrounding. Theta is mean temperature during interval, whatever.
Yes.
So what is K here?
Constant.
Yes, as usual. It's a constant.
Yes.
Is it recording? Yeah.
Yes.
Okay. It's a constant
Yes.
which depends on area, how much area it is covering.
Yes.
And some more thing, it's nature. What's the nature of that thing, of material or surface?
It. Yes, sir.
Okay. Done? Shall I scroll?
Yes, sir.
Are you writing with me?
Yes, sir. I'm writing, sir.
So that like you don't have to spend time for writing again.
Yes.
Okay. Fine. So let's write some points about this one, Newton's law. Newton's law can be applied. See, like when they ask the question is for explaining and statement. So we can write statement and we can explain this one with this one more statement. We can write that.
Yes.
This can be explanation. And with that, they were asked for one numerical, right?
Yes.
I will not do same numerical that you will solve. We'll do some similar question.
Yes, sir.
So that it's not necessary you will get same question in your exam, right?
Yes, sir.
Yeah. Okay, so we can apply this only when temperature difference. Same thing we are writing in explanation form.
Yes, sir.
Only when the temperature difference between body and
Surrounding.
exactly surrounding is small. That's why we wrote delta T. Cooling should take place. We are writing this statement from the example of coffee.
Yes, sir.
Only due to radiation. What are the condition? Should take place only with the radiation, not with like we are adding more cold water and something like that.
Yes.
Radiation meaning you know, right? What is radiation?
Radiation means like emission of energy, like that.
Yeah, emission of energy.
Waves.
Radiation, convection, conduction.
Yes. 3 methods to lose
Yeah.
conduction, convection, and radiation.
It's not changing. So it should take place due to radiation. Okay, I'm not sharing it. Only due to radiation.
Yes.
And there should be no loss of heat due to conduction. Because there will be more loss of heat due to conduction.
Yes.
Even in radiation also there is a loss of heat. So what we wrote 2 points. Newton's law can be applied.
Only when temperature difference between surrounding is small.
And second one,
the cooling should take only due to radiation. There should be no loss in heat due to conduction.
Conduction. So can you remember these 2 points? And with this,
Yes.
yeah?
Yes, sir.
Okay, shall we do some numerical or shall we go with some more theory part in this one?
The numericals.
Numericals. Okay. I will help you with this question. You give me another question. Sorry,
Yes.
you will solve that given question. Exam in that paper you showed me, right?
Yes.
Yeah, this one I will try. It's similar. Let's see. Wait. 60 degree to 50 degree Celsius in 5 minutes.
Yes.
The temperature of surrounding is 30 degrees Celsius. What is the time taken by the liquid from 50 degrees Celsius to 40 degrees Celsius? Okay. So what are the given things? Theta 1, theta 2, they're directly proportional. That's what they're giving. Okay.
Yes.
So how to start? From the Newton's law of cooling. So from or by Newton's law of cooling. So what they say is rate of cooling is directly proportional to
difference between temperature of system and surroundings.
exactly. Difference between object, or sorry, body and surrounding. So rate of cooling is directly proportional to mean difference between object and or body and surrounding. So there we wrote there theta minus theta 2 by T, right?
Yes.
Theta 2 minus theta 1 by T, rate of cooling. So rate means divided by time. T is
Yes.
proportional to theta 1 plus theta 2 divided by 2 because mean difference we need to find out.
Yes.
This is not Q, this is theta. That is subtracted by theta naught.
Yes.
Mean difference of object and surrounding, this one and this one, mean difference.
Yes.
So now in question, what they're giving conditions, let's see. First it was 6250 in 5 minutes. Time is given. If temperature of surrounding is 30 degree, what is the time taken by the liquid to cool from 50 to 40? First 62, 50 we need to find out, then 50 to 40. Theta naught is given 30 degree. Clear?
Yes.
First we will use 50, 60, 50, then 50, 40. But
Yes.
our surrounding temperature is fixed, that is 30 degree.
Yes.
Okay. 60 and 50, yeah. I'm just remembering values. Okay, it was time, T is time taken to cool. From theta 2 to theta 1.
Yes.
And theta naught is temperature of,
Surroundings.
so we are writing again and again so that we will recall it again. So it was 60 minus 50 first, and this is 5 minutes is proportional to what was this? 60 plus 50 by 2 minus 30.
30.
Okay. So what you will get, 2 is proportional to 2, right? 10 by 2. This is 110 by 2 means 55. 55 minus 30, which is 25. Two is proportional to 25.
Yes.
Okay, this one, this is, let's take this as a condition 1.
Yes.
In second condition, what they said, what's the value? 50 and I think so 40, right?
Yes. 40 and 50.
50 and 40. Same manner, 50 minus 40. Here we don't know what's the time. Is proportional to 90 by 2 minus 30. 10, again 10 by T is proportional to 45 minus 30, that is 15. I write directly here.
Yes.
This one 40 plus 50, that is 90. 90 by 2 is 45. 45 minus 30 is 15. You understood this one, right?
Yes.
Sure, right?
Yes, sir.
If you don't understand anything, just tell me there itself. Don't feel shy to say. There's no one here.
Understood.
Yeah. Okay.
Yes, sir.
Yeah, this is easy only. Nothing here. Still, you can ask if you can't. So dividing 2 by 1. Equation number 2 by 1.
Yes.
So what will you get? Divide and tell me.
Yes, sir.
Or 1 by 2. 2 by 1, 1 by 2. Doesn't matter.
2 by, I'm doing 2 by 1, sir.
No problem. Anyhow, we need to find t only, right?
Yes.
What you will get? It will be, oh, sorry. Two, 10 by t divided by 2, 15 divided by 25.
to 15. The 20 by t is proportional to 3 by 5.
Then remove proportionality, write equal to sign and find out t.
Yes.
2 by this one, right? So 10 by 2t equals to 15 by
10 by 2t.
So t equals to 25 by 3, I guess so. 8, 3 is a 24, decimal 1. How much is this? I don't know, check it. This is correct only, no? What's the answer?
What they're doing, sir?
Just 2 decimal is enough.
$8.33.
8.33. What's the unit?
Seconds.
Seconds. 8.33 seconds. Okay. Let's try your question. What's the question? Let me write here. Oh, it's same question only. No, small difference. Yeah, it's a small difference. Similar question, see? But small difference, that is temperature is not given. You have a question with you or shall I write question here? Let me write them.
Yes.
Okay. Try yourself. No Google uncle. Doesn't matter right or wrong. You try yourself, okay? That's
Yes, sir,
what
I'll try.
we are here for. So body question same like a body cools. Degree in 5 minutes, and to 40° in another 8 minutes. Surroundings. Okay, try this.
Sir,
Similar
here
way.
in this previous question, 10 by t by 2 is 20 by t, no, sir? How you got it? 10 by 2t.
10 by
T by 2 means 20 by t.
nahi. Am I wrong? Did I do something wrong here?
I think so, sir. Means
I don't like. Let me check. You're saying 10 by t
t
by
by
2.
means 20 by t should come, like it's become
No,
reciprocal.
this whole term will come down. That means if I say like this, 10 by t as, if I reciprocate it, it should be 2. No, this will come down only. This term will come down. 10 will be here. 10 will be here. It will be 2t. No, correct only. Not wrong.
Yes.
You're not getting this point?
I got, sir. I got.
I will just divide it. That's it. 10 by t. It was there. And whole divided by 2. If it is 1 by 2, then it will be reciprocal.
Yes.
It will be 10 by t into 2 by 1.
Yes. Yes. Yes.
Try this. You'll get
Yes.
around 30 only because we took here 8.33. Here they are taking 8. So it will be not exactly.
Yes.
Oh, then by the way, this should be in minutes, right? Not 8 seconds,
Yes. Yes. Yes.
right? Yeah, that we didn't think thought of it. Because why I'm saying this, because this is in minutes, 5 minutes. We didn't convert. That means this should be in minutes. Did we convert it here? Nowhere, right? No, 5 minutes only. No, we didn't. That means it's 8 minutes, not 8 seconds. Come on, try this.
Sir, I'm doing.
Acha, okay. Good.
10 by 2 is sir, and so means here 50 to 40 here is 8 minutes.
Sorry?
60 to 50 means 5 minutes. Means 50
Yeah.
to 40 is 8 minutes, sir.
Yeah.
Yes.
We need to find out that subtracting temperature. We have 30, right? For the previous question, here it will be something similar.
Mm. So 2 is plus. Mm. Mm.
Anywhere you stuck somewhere?
No, sir, I am almost getting 60 plus x squared. And this is 2 by 5 by 4.
Yes. What do you say?
So I got like this: 2 by 5 by 4 is equal to 60 plus x by 2 by 50 plus x by 2.
Okay, equate it and find the theta naught.
Yes, fine.
Equation number 2, equation number 1, divide. Okay.
Yes,
I'll give one more question as a homework, then we can,
yes.
I'll type here till then. Because we need, for one more question we have to solve, right? So that is, you gave the 3 vector for me or it's for maths you gave? You want scalar triple product, right?
Yes, sir.
Actually, this topic is in maths, right? Triple product.
It is also there in physics, sir.
Yeah, we'll do it. Not a problem. It's easy only, nothing big here in scalar triple product.
Yes.
Just what we did in 2 products, just add one more product. That's it. I'll write here all properties.
Yes.
Then first one. Go to
First
second
I
one.
got,
Second one is your homework.
yes, sir. First one I got like minus 100 by 9.
Theta naught equals to minus 100
By 9.
by 9 means 10 degree. No. Okay, tell me the equation. Okay, let me solve first. Let me solve. So I just directly write here. But when you write in your exam, start with this way, what we did for first question.
Yes.
Newton's law, by the Newton's law of cooling, this rate of cooling is different by rate of explosion, blah, 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 and all these things. You have to write those things.
Yes.
I'm writing directly here. So 60 minus 50 by 5.
Yes, is equals to 60 plus x by 2.
5
This one.
equal to 60 plus 50 by 5. No, 2, right? Oh.
That means how it's 50 means we don't know the temperature of surroundings, no, sir.
No, we don't know temperature of this one.
Oh, sorry.
Here, what we wrote here, theta naught, we wrote somewhere here. Where it is?
Yes, sir. I confused. I confused.
See, theta naught is the temperature of surrounding.
Yes, sir. I from the start I was doing wrong formula, sir. Yes.
Now can you get it, right?
Yes, sir.
Same way, 50 minus 40 by how much minute? 8 proportional to 50 plus 40 by 2 minus theta naught.
Yes.
So from here we'll get equation number 1. From here we'll get equation number 2. We will divide.
Yes, sir.
Divide them.
Yes, sir.
Now you can get it, I guess so, right?
Yes, sir. Yes.
Okay. This similar way you have to do question number 2 also. It's
Yes.
same thing.
Yes, sir.
but you have to do third time, 3 times. See, first here to this one, 5 minutes, and this one to second one for 5 minutes, and second one. So we need to find the third one temperature, that is room temperature.
Yes, sir.
And the body temperature. So 3 equation, 2 unknown.
Yes, sir.
Or 2 equation, 2 unknown. Let's see what you will get this. But what I think, from first and second equation, you will get room temperature, surrounding temperature. Fine.
Yes.
Right. Okay. See, take this as a hint for second question. Similar way, what you did for this one, same thing you do, find your theta naught. Now use this theta naught to find another temperature. That is this temperature.
Yes, sir.
Another is this temperature. We need to find.
Yes.
Use that room temperature, surrounding temperature to find this theta.
Yes, sir.
So that's what your hint. You can try this. It's a little bit lengthy question. You can try. And if you don't get it, text me in that one group. I'll show you the solution. I'll solve and give you back.
Yes.
Okay. Shall we go for next part? Because
Yes, sir.
yeah, this time will get over. So we need to solve. It's okay if you do. You have any continuous class with this?
Sir,
What is the other class timing after this?
after this I have like maths.
Maths at 3 o'clock or 4 o'clock?
4 o'clock.
4 o'clock. Okay, so that means you have still time, right?
Yes, sir.
So this vector question will take a little bit time.
Yes.
Okay. This is what? Scalar and vector of triple product. So let's start with the basic, that is let there be a 3 vector. As A, we're taking A, B, C, not X, Y, Z. Doesn't matter. Any 3 things we are taking. A, B, and C. So I can write this ABC as A, B vector, C vector. Now, this is very easy. If you just listen carefully, it will be very easy to understand. Okay? I'm going it very slowly.
Yes.
Okay. So this is having like dot and cross product like that. So let's write those first. A dot B cross C. I'm writing few dot and cross products.
Yes.
A dot B dot C A cross B dot C A cross B cross C A dot B cross C then we need A also, right? Okay. A cross B dot C vector. And some more we'll write some examples. A cross B dot C in bracket. Then
Yes.
A cross we wrote? No. So then A cross in bracket B cross C cross. Okay. Okay. So from this 1, 2, 3, 4, 5, 6, 7, 8 operations, see this in bracket, let me change the color. Okay. In this bracket, whatever we have like a multiple or like a dot product in the bracket, those are scalar product, right? So they
Yes.
are like meaningless. So we are just considering those which have cross product.
Yes.
So here, so these things we cannot do any operation in this one. So we are not going to use them, or we will eliminate this. We will just use this part 1, 2, 3. Anything left? Fourth one.
Yes.
So let's write A cross B C and A dot. Let me write this A dot B cross C then some A cross B dot C, this two done. Now what we wrote these two are scalar triple product.
Yes.
Because if we give this one, if we use dot product here, we'll get scalar triple product.
Yes.
Okay, and remaining two, what are the left? All the cross products. A cross B cross C and A cross B cross C. These are
Mm. Plus
vector.
vector.
Okay, vector triple product.
Yes.
Now even this scalar product, there is another name, that is box product.
Yes, sir.
So why they name this or these things scalar and triple product and all that? Because this product of this one will give you scalar quantity, and product of this one will give you vector quantity.
Yes.
Same thing. Okay, so let's go with geometrical interpretation. Of scalar triple product.
Yes.
Suppose, let me draw a shape. They are C and B. They are some product scalar. Okay. There are some quantity of scalar, which is A in the direction of this way. See? So if I join them and if I make it like represent in this form, let me draw it. A, C, this is B cross C with angle phi. This angle is theta.
Yes.
This is what parallelogram. So what is area of parallelogram? We can say that
Area of parallelogram.
yes, sine theta. If I want to write B cross C, how will I write? B mod C sine theta,
Yes.
which is equals to area of, this is parallelogram, right?
Yes.
By vector B and C. So formed by B and C.
Yes.
So vector we have like B cross C and A, we have 5. So C and B we have theta. Okay. See, let me just download one picture so that we can understand better. One sec.
Yes.
Because here I'm not able to show you properly 3D diagram. Yes. Got this one image. No, not this one. Yeah. Here in picture they have taken difference, but our values are different. So don't get confused with that. I just want to show you. We have taken A, B, C. They have taken different. Yeah, this is what I'm trying to show you. So compare with us, ours, we have B and C here, right? So they have taken A and B. Phi is same, A is different, and here we have C. So let's change that thing. Here we have C, right? And what was this one? B.
Yes.
And what was here? A, right?
Yes. A.
Angle theta was angle here. No, this side.
Down.
Theta. And this is B cross C.
Yes.
Is it same now? A, C, B. Okay. Okay. Then let's write in 3D form. A vector dot B cross C. See, whatever I'm using alphabet, you just see diagram first, then you write. Don't write right now. I'll give you time. You just see diagram and follow that diagram,
Yes.
which is equals to, we wrote B and C mode of, writing here, this one as A cos alpha, not alpha, we have 5. Sorry. Cos 5. No, let me use some other color. Here, A perpendicular vectors here, right here.
Yes.
So A cos 5. And this will be sin 5. That we don't require here. So let's write here. That is mode of A cos 5. So A vector dot B cross C vector equals to area of parallelogram by
Yes.
B and C vector. So this one will be equals to this, if you take this whole cube. So A dot B cross C vector will be equals to volume of five. Okay.
Yes.
Which are at what this one edges A, B, C, we have written here already.
Yes.
Which determines, if we write here A, B, C. I'm not writing that. Make a note. We have taken here A, B, C. In some other book, it will be A, C. You have B, C, doesn't matter. A, B. Meaning is same. In short, we are finding same thing.
Yes.
Done. Shall I scroll?
Yes, sir.
Okay. So this terms you know already, I think so. Let me show you. A vector I can write as A1I plus A2J plus A3K.
Okay.
Same way for B, same for C. Right. Now, if I take this value and multiply here, so what should I do here? A
Dot V cross.
cross C. Now, if I multiply here, I need to write this whole term of A dot whole term of B cross whole term of C. Right. So this after this multiplication and cross product will be like a little bit so lengthy, not little bit, it's so lengthy. So for that we have something that is determinant. Let me show you directly that.
Yes.
You write your whole term, but I don't have space here.
Yes.
A1 I cap plus A2 J cap plus A3 K cap
Yes.
dot of vector BC. We will take I J K. Have you studied determinant?
Sir.
Have you studied determinant?
Sir, I know determinants matrices.
Okay. Oh. This is 2. Now, if I solve this I for this 2, then J for this 2,
Yes.
K for this 2.
Yes, sir.
Try this. I'll write direct answer here. You try multiplying.
Yes, sir, I'm doing.
B1 C3 minus B3
Yes. I got same.
J plus B1 C2 minus B2 C1. Now II, JJ and KK. A1 we can write as B2 C3 minus B3 C2
Yes.
Is it right?
Yes, sir.
Minus we have A2 as B1 C3 minus B3 C1 plus A3 with B1 C2 minus B2 C3. Now this one we can add this way as A1, A2, A3, B1, B2, B3, C1, C2, C2. Then we can find determinant for this one, we'll get answer. And properties are similar to that of scalar 2 products.
Yes, sir.
You know properties of scalar 2 products?
Yes, properties of scalar products. Yes, sir.
Yeah. Shall I show you? I taught this in system of particles.
No vector. Yes, sir. I know properties of vector products. Scalar.
Similar. Just add third term. I'll just show you round off. Yeah, this one.
The scalar. I know some properties.
Yeah, this
A
are
dot B
properties.
is equals to B dot A.
Exactly. They are not communicating. The change on reflection means A will be
This is
minus A. A is equals to
vector
minus A.
product, no, sir.
Yeah.
Scalar product means
See, that is
that
direct
also I
one.
know.
Similar
Yes,
one.
yes, I know. Yes.
This is 2 terms here. We have done 3 terms.
Yes.
A and B. We have here A dot B cross Q. Okay. So you solve this here, you will get answer. Means like with the values, we'll have values here, substitute values, and determinant. You know to solve determinant, right?
Yes.
Hello.